All right, let's jump right in. We're going to do a deep dive into TCPIP and DNS to tackle that one question that gives every developer and sysadmin a headache. Why on earth is my app unreachable?
You know the feeling, right? The alert goes off, a ticket comes in, and your app is just gone. It feels like you're searching for a needle in a haystack the size of the entire internet. But trust me, there is a system to the madness. You see, every single connection, no matter how complex it seems, really just boils down to two very basic questions. First, can we find the server? That's a DNS question. And second, once we find it, can we actually talk to it? And that's all about TCP. Find and talk. That's it. That's the whole framework. So let's start with the first piece of that puzzle, DNS, which is all about finding the right address.
The whole concept here is actually pretty simple. The domain name system, or DNS, is quite literally the internet's phone book. Its one and only job is to translate a name that we humans can remember, like example.com, into an IP address that machines understand, like 192.0.2.1. Without this, we'd all be trying to memorize long strings of numbers, and nobody wants that.
So how does that lookup actually work? Well, assuming it's a new request, your browser asks a kind of helper called a recursive resolver for the IP. In this resolver, it goes on a little journey. It starts at the top, asking a root name server, which points it to the right top-level domain server, the one for all the .coms. That TLD server then points it to the final boss, the domain's very own authoritative name server. And that server is the one holding the prize, the IP address, which it hands all the way back down the chain to the resolver and finally back to your browser. It's a super fast, hierarchical scavenger hunt across the web.
Now, when that final answer comes back, it's usually one of two flavors. You've got your A record, which stands for address. This points directly to an IPv4 address. It's the X on the treasure map. Then you have a CNAME, or canonical name. This one's a bit different. It's an alias. It points to another domain name, not an IP. So think of it as a clue in the scavenger hunt that says the treasure is wherever this other map leads. A CNAME always means you have to do at least one more lookup to get the real IP address.
Okay, so picture this. You've fixed a broken DNS record. You tell everyone it's fixed, but the site is still down for them. Sound familiar? If you've ever been pulling your hair out wondering why your DNS fix isn't working yet, the answer is almost always a little thing called TTL.
And here's why. Time to live, or TTL, is just a number on every DNS record that tells resolvers how long they should cache or remember that record. Now, a high TTL, like 24 hours, is awesome for performance because resolvers aren't constantly bugging your server for the same IP. But it's a nightmare if you need to make a fast change. On the flip side, a low TTL, like 60 seconds, lets you pivot quickly, but it puts a lot more load on your name servers. It's a classic trade-off between performance and agility.
Okay, so DNS did its job. We found the address. Now comes the second part. We have to actually talk to it. And that brings us to Section 2, TCP, the art of making a connection.
TCP, or Transmission Control Protocol, is basically the set of rules for having a polite and reliable conversation online. After DNS finds the right house, TCP is how you knock on the door and make sure that every word you say gets delivered in the right order and without any mistakes. It's kind of like the internet's version of certified mail.
And that conversation always starts with something called the three-way handshake. It's simple. First, your computer, the client, sends a SYN packet. That's basically it saying, hey, can we talk? If the server is listening, it replies with a SYN-ACK packet, which means, yeah, I hear you, let's talk. Finally, your client sends one last ACK packet, saying, awesome, conversation started. And boom, the connection is live.
But what if that handshake fails? Well, one of the most common errors you'll see is connection timed out. This is a total black hole. Your client sends that first SYN packet out and crickets. Nothing ever comes back. The usual suspects? A firewall somewhere is just silently dropping your packet. The network is incredibly congested, or there's a routing issue deep in the heart of the internet.
Now, the other big failure mode is connection reset. This one's different. This is an abrupt hang-up. The server doesn't ignore you. It actively sends back a reset packet. It's basically yelling, go away. This usually happens when a server is just too overloaded to accept another connection, or sometimes a security device in the middle decides it doesn't like the look of you and just kills the connection.
All right, theory's done. Let's get our hands dirty and see how this works in the real world. Section 3, Live Diagnosis, taking something from down to debugged.
So here's our scenario. We get that dreaded support ticket. All it says is, the site is not loading. Super helpful, right? But it's okay, because we have our two-question framework, find and talk. So let's use it to figure this out.
First things first, we have a name, but can we turn that name into an IP address? Step 1, can we even resolve the name?
For this, we're going to use the nslookup command. We run it on our baddomain.com, and look at that. The output gives us a status of NX domain. That is a crystal clear message. It means non-existent domain. The internet's phone book has no listing for this name. And just like that, we found our problem. The DNS record is either wrong or it just doesn't exist.
Okay, but let's change the story. What if nslookup did work and gave us an IP? Our DNS is fine, but the site's still down. This brings us to the next logical question. Can we actually reach that IP?
For this, our tool is ping. Ping sends out a tiny little "Are you there?" message and waits for a "Yes, I am" reply. But when we ping our IP address, all we get back is "request timed out" over and over. That means our little messages are going out, but they're getting lost in the void. No reply is coming back. The server's either down, overwhelmed, or, more likely, a firewall is blocking our pings.
So our ping is timing out. We know we can't reach the server, but the internet is a vast network of connections. Is the problem on our end, their end, or somewhere in the murky middle? This leads to our final question. Where exactly is the path breaking?
And this is the perfect job for traceroute. This command maps out every single router, or hop, between your computer and the destination. What we're looking for is a pattern, and here it is, a line of 3 asterisks. Each one of those means a router along the way didn't reply. When you see a whole line of them and everything after it is also asterisks, you've just found it. That's the spot where your packets are starting to disappear. See, when you follow that logic, you get a repeatable, powerful step-by-step method. So let's wrap this all up and put it into a neat little package in our final section, your troubleshooting playbook. It really just comes down to this simple 3-step playbook that you can use every single time something goes wrong. Number 1, nslookup. Check the name. Are you even getting an IP address? Number 2, ping. Check for reachability. Can that IP address even hear you? And number 3, traceroute. Check the path. If it can't hear you, where is the connection breaking down? Name, reach, path. That's all you need to remember.
And that's really all there is to it. It's about having a simple framework to tackle a complex problem. So, the next time your app goes dark and everyone's looking at you, what's your first command going to be?